Today's lecture, as you all know, is supposed to be about test-driven development. However, we're going to split it into TDD and one other thing. So the other thing I want to talk about here very briefly is how to problem solve. So let's see if I can come up with a good problem. Or we can actually just reference something that you guys had in the homework. Let's see if I can pull this example up on my other screen. Uh, yeah. Did everyone tackle the linear search problem?
The one in JavaScript.
Yes.
Oh yeah.
All right. So you guys all remember roughly what that was? Or if not, that's totally fine too. All right. So if we didn't get to it, we'll talk through. So this is again an example of a problem that I just want to use it as an example of how we can break down a problem from something weird and nebulous into code. So not the one non-benefit of having two computers instead of two screens is copying between them becomes a little bit impossible. So let me go ahead and copy the prompt in here once this loads. Oh boy. All right. All right. And let's go here. So the first thing is all of this stuff is simple English. This is not Python. So I'm going to turn this into a comment by putting hashtags at the start. If you're on Windows, you can do the same thing by doing control and then slash. And okay, no. We're not going to look at the hints. And I am not trying to run something right now. So the first thing that we want to do when we have a problem like this is, let's just do return, just so that we don't start getting funny looking errors. So the first thing that we want to do when we have a problem like this is you want to read the problem. That's really it. Read the problem and try to figure out if you understand what's going on. So, all right, so we need to write a function that takes in two things and returns an integer saying where it shows up. And the nice thing is some problems don't give you examples. This one does, which is great. And of course, the notation is not going to be the same thing in Python versus in JavaScript, but for now, we'll just forget that. So what I'm basically saying is we have, we have a list of things. We have a thing to find in that list. And we are not going to, okay. This really wants to try prompting me. I need to switch this off once we jump off the record. But we need to find, we have a thing to find in that list. We need to return the index of that thing in the list. Okay. So where do we go from here? What should our first step be? So, well, I guess the second step. So the first step in problem solving is read the problem and simplify it down to something simpler. Without all the jargon, without all the fancy English, you can use the words thing and stuff and return. Like it is completely fine to keep it in very simple cave person-y language. That's totally okay when you're first tackling a problem. So how do we do that? How do we find something in a list? Open
Have a
question.
list.
Sorry, you go ahead.
Have a list.
Okay, so let's say we do have the list. So how do we find a thing within the list?
Like
Index.
in code word or just plain English?
Let's talk in English. English is
All right.
probably good.
You start looking for it. I mean, I guess like you look for it, whatever bag, right? You find out what bag it's in, or start looking for it.
Okay, so how do I do that?
You compare things.
Okay, what do you mean by that? Explain.
So if I'm looking for something, usually I either have like something I'm looking for, an item, or I have a name or something. Okay, gotcha. Got find thing list.
So let's think through this in like a life example. This is something that I like to do as well when trying to figure out coding problems is create an example of it that's kind of relevant to your life. Let's say that you walk out of the house, you get to your car, and then you realize by the time you get to your car that you forgot your keys. Now, in your brain, you're like, okay, I don't have my keys right now, but I need to find them. So in my brain, I have a list of locations, let's say, where my keys could be, right? They could be in the coat closet. They could be in my jacket pocket. They could be in the kitchen sink. Not sure why they'd be there, but it's always possible. And you develop a list in your brain of locations where those keys could be. So as a normal human being, how do you go about figuring out where your keys are
you
after checking
go
your
to
pocket?
those.
I heard
Work
three people.
backwards.
Okay, work it. We could work it backwards, or equivalently, you could work it forwards. But you got to go through the list, right? I think is the point we're making. So we got to go through the list of places and figure out is the key at this place. If it's not, move on to the next one. Does that make sense? So let's write that out. So go through the list at each point in the list. Ask ourselves, is the thing I'm looking for? Yep. Okay. The AI is already being genius. If it is, then return the location where we found the thing. If it's not, then keep going through the list. Right? So again, if we think about that, like with losing your keys, first you're going to retrace your steps along the path, going from your car to your front door. You check along the path, you don't see it there. You check in your closet, you don't see it there. You check in your jacket pocket. Aha, it's in the jacket pocket. So, okay, now I know my keys were in my jacket pocket. So that's kind of like the location kind of acts a little bit like an index. Now, Logan raises a good point. Hypothetically, your keys could be, disappeared by like an alien shrink ray or something like that, and you never find them. So that is a possibility. It's also a possibility in this example. So if the thing is not in the list, then we still need to return something. What's the thing that we should return? And this is telling you should return undefined. Another option, instead of undefined, you could also return like -1 is another option, right? Which in some languages is not recognized as an index. In Python it is, but that is another option. But for now, we'll do undefined. So the thing that we just wrote up is basically a game plan for how we can solve this problem in simple English. Now our challenge is we have to go from that simple English to code language. More specifically, we got to go in Python. So let's start doing this. No, let's start doing this in our define linear search. Actually, just for purposes of lecture, I'm going to pause the recording for like 1 minute while I go and switch off the AI coding here, which I should be able to do up top. So give me 1 sec while I do that. And also, all of you guys should also have this switched off too, because it really is not helpful for. Let's resume that recording now that the annoying AI is turned off. Okay, so let's start from the top down. So we have a list of things. That's target. We have a list of things. That's the array. So I'm going to rename from array. This is a list. We're in Python. So we're going to call this thing list to search. And then we've got target, which is a thing to find. And we know we have to return the index of the thing in the list. So I might as well just make a variable and call it index, right? Or to be more specific, let's call it index of target. And I need to set that to something. So what's a good value we should set it to initially? Anyone have a suggestion? Yeah, 0's not bad. Well, let's try that for now. We can go back and let's make a note. Let's say, no, this is an arbitrary value. May need to change this later. Okay, cool. So now we got to go through the list. How do I go through a list in Python?
A for loop.
Why do we want to use a for loop?
Because it can iterate through every letter in the list.
Bingo. Yes. So for loops are great. That should be your number one tool in most cases for going through a list. For loops and lists go hand in hand. So, how do I want to iterate through the loop? Let me give you a suggestion. Should I just say for thing in list to search? And then
No.
why not? Now let's take someone other than Michael for this one, and we'll come back to you.
Check for the length.
Sorry, say that one more time. It was a little faint.
You want to check for the length of the list?
We do. That's true. But there's more to it than that.
Do you? Well, I'm sorry. What was the question again?
This is correct Python format. But is this the way that we want to search through the list?
I think the better way, or there's a more defined way or a more narrow way to do it where you have the start, stop, and an increment.
Yes. So again, in Python, there's a couple ways to search through a list. The cheat way of doing it is by doing this. And I can just show you guys what that looks like. So here we can just do like a print thing. I'm also a huge fan of like testing my code as I write it. So I'll just write stuff out, put tons of print statements in there, and just let the code start going. So let me create a list to search. So we'll say my list is going to be A, B, C, D, E, F, G. And let's say that oopsies.
Hello?
Oh, go ahead. Yeah, we can hear you.
Oh. No, sorry, I was just kind of just wondering, like, for the for thing in list search, why do we have that there again? I'm sorry, I got distracted a little bit.
Oh, no worries. So what we need to figure out how to go through the list, as we said on line 17. So this is an option for how we can go through the list. However, this is not the best option, and I'm going to show us why in about 5 seconds here. So let's just run like what the code we have right now. So let's put in my list and my target. So what do when we run this code, what do we expect this should be output? Or this should output? Like what should come out on the screen when I run this code as it stands right now?
It should
Gonna print that whole list.
Yeah, it'll print the list, right?
And then letter C as well.
It shouldn't print C.
Oh no. Oh.
Yep, it should just print whatever is in the list, right? So if we look at 27 and 28. So let's just make sure that's true. So let's run our Python file. And yes, we see that it does indeed print out the list. So that's good. But if we go back to what we talked about, and I think Jose alluded to this, is what we want. Do we want to print out, do we want to check the elements that are in the list? Or do we also need their indices?
The index.
Yeah, we need the indices. What I just printed out does not have any indices. So, Venetia, since you mentioned indices, is this a good solution for us to check the indices of stuff when we're going through the list?
You probably want to start with like a number.
Yeah, we're going to need to start with a number. So the way that we can do that, as Jose alluded to, is we can use that handy dandy range formula. So let's just go ahead and get the length of the list first, which somebody else mentioned. I forget who, so I apologize. Let's just say length of list is going to be list. It's going to be the length of list to search.
I should probably write this down.
So we'll just print out the length of list, just again, because I'm a big fan of print statements, and just also just to make sure that my code works. So let me delete this for loop for now, and we'll just rerun it. So how many things are in this? 1, 2, 3, 4, 5, 6, 7. So ideally, if my code is right, length of list should be 7. That looks right. It's 7. Okay. So now let's go through and iterate through the for loop the other way, the way that does it by index, right? So let's do for index in. Now, how do I iterate through the indices of a for loop? I forgot.
I'm sorry, what are you using calling to execute? Is it just TDD.py?
So I'm using the run Python file button at the top right, which is the little triangle. This is a cheat way of saying Python tdd.py. They both do the same thing.
Okay, thank you.
So
As you can see, I
sometimes,
have syntax error.
sometimes I click on the play button on the top right and it doesn't do anything. Could that be like a setup issue?
That's probably the case. Yeah.
Okay.
So this is usually why
Probably reach
this
out
is
to
usually
someone
why we
else
use
out
the
there.
Python in the console, because it's mostly a surefire way to get it right. All right, so back to the loop. So again, as Venetia and Jose and others alluded to, we need to go through the indices of the loop. So how can I do that?
For loop.
Okay, yep, so we got the for loop.
Define your conditions.
So how do we define the conditions?
You'll
So
put it in
you
the.
put- sorry.
No, go ahead.
From what I remember from yesterday, it was like you have a start point, an end point, and then you have like a counter of how many increments you go up or down.
Yep. So, but that's all within something called a range,
Right. Yeah.
right? So it says it right here. So you got your range. You can either just put the stop, or you can do the start, stop, and step. So in our case, let's just do the stop. Actually, no. Let's do the whole thing. Let's do start, stop, and an increment. So what's the start point?
It'd be the index, right?
Zero.
Is that what we're saying?
Yeah, we got to start at 0. 0 is the first thingy in the list. Remember, Python is a 0 index language. So A is at index 0. B is at index 1. C is at index 2, 3, 4, 5, 6. So if we want to go through the whole loop, what's the index of the last thing in the loop?
-1.
This is true, but that's the cheat code answer. What's the
be
positive
all
number
in.
answer?
Would it be n+1?
What would n be?
Or would it be just 1 if it's just counting?
Well, again, we're trying to figure out where the end of the list is. So if 0 is the start, and I already said that, so G is going to be at index 6, right? So 0, 1, 2, 3, 4, 5, 6. Now I can't. I
So
could
that's
write
one.
6 in here.
The
But
end
that's
is the
No.
length of list.
Length
Go
of
ahead.
list.
Length of list.
Okay. So length of
Plus one.
list.
Minus one.
Would it be?
So let's-
Would it be?
Minus one.
Wouldn't it be the syntax that's above there, the length, and then list to search in parentheses?
Yeah, so that's the number that we have here, right? So length of list. So it's going to go from 0
Oh, gotcha.
to length of list, and then
Okay,
the counter
yeah, I see.
is 1. All All right, great. So now we're finally searching through all the indices, right? So we're going through the list. So now we got to do this part. At each point in the list, ask ourselves, is the thing I'm looking for the thing at the index, each in the list? So let's say, so thing at index. What is the thing at the index at IDX in this list? How do I access an element of a list? All right, let me try calling on people who I haven't heard from yet. August, any ideas?
Not really. Can you repeat the question, please?
How do you access an element of a list?
Would you have to write down their indices or?
So we have the index, right? That's what we just
Yeah.
established. That IDX is the index, and we're just trying to figure out what the thing in the list at index IDX is.
I'm not sure.
Okay, no worries. Let's see. Who else have I not heard from yet? Nicholas, any ideas?
It's the list of search, open bracket, IDX, close bracket.
All right. So here, let me paste this in, and we'll do IDX. Okay, cool. So here's what I'm going to do. I don't believe you. I think that this code doesn't work, or I think it might not work. What's the way that we can test this? Print statements. Print statements are the surefire way to test everything. Well, not everything, most things when you're working through it. So what I'm going to do is I'm going to print out index, and I'm also going to print out thing at index. So what do we expect that this should print out when I run this over my list?
Should print 0 and then what's in the actual list to search at each index, but it'll start at 0 and count up.
So it should do like 0. Yeah, so 0, A, 1, B, 2, C, and so on. So let's make sure that that actually works. All right. 0A, 1B, 2C. That seems pretty good, right? Do we all agree that's what we expect? Okay, great. So we don't need those print statements anymore. So we found out what the thing is at each index. And now we have to ask ourselves the question, is our target the same thing as the thing living at this index? How do I check that?
If
So
statement with an if statement with the thing you're looking for, and then the double equal sign, and the thing you're looking at.
Perfect. Yep. So if that is the case, what do we do?
Return that index.
Awesome. All right, return the index. What if it's not?
Keep looking.
Yeah, let's continue. Okay, great. So we did the if it is, we did the if it's not. Now here's the last part, right? We went through the whole house and we couldn't find the keys. So if the thing is not in the list, we ran through the whole loop, but we never returned anything. We now have to return none. It was not found. So if my target is C, C is in this list, we expect it should be found at index 0, 1, 2, right? So I'm going to just go ahead and print out the results now since I'm returning and not printing anything. So this should hypothetically return 2. Yeah, it does. So it looks like my code works in this instance. Let's try another index. Let's try F. So F is at 0, 1, 2, 3, 4, 5. It should return 5 now. All right. And then let me also put in phone. Phone is not in my list. So this should go through the whole list, not find it, and then return none at the end. That it does. So hopefully this helps everyone with number one, the solution to linear search, if you haven't gotten to it, but also how we went from this kind of yucky looking problem that is in coding gobbledygook to relatively simple English to life example to going through our simple English line by line and converting that to code and then testing it piece by piece until we have a working solution. Does that overall process make sense? Anyone have questions or comments about it? And yes, I will put this in the chat shortly. Not right now, because there's one or two other things that we're going to do.
I do. So can you go back over to where it says list to search real quick?
Mhm.
And I was following length of list to search. I don't know what it looks like. That's a variable, correct? Or
Yes.
but I don't see where that variable's at in there. Is it just a like dynamic? It could be any list to search. Is that what we're saying with this?
So all we're doing for length of list, that thing's just holding the length of the list to search. So that way we're not
Okay.
hard coding the length of the list, right? So I could change this
Okay.
list to be every letter in the alphabet, and the length of the list would change to 26.
Gotcha. Okay.
I mean, we don't even need this variable. I am a big fan of adding variables to make code cleaner and easier to read. Like, I could just put this in here automatically, but you might be like, wait, what is len list to search? What does that mean? Oh, if I have a variable that explains it, that's just like, aha, okay, so I understand what that means now. All right. Any other questions about that?
Yeah, because it's a parameter. Okay, that makes sense.
Yep.
I had a question. So we use the length of the list to determine when to stop the loop in that case, right? So why couldn't that have been a -1 if -1 is like always the index of the last thing?
That's a good question. So, all right, here, let me first try to figure out how to stop my computer from lagging. All right, also, hopefully you all can still hear me, because my thing is deciding to start freezing up, which is not a great start. So if at some point something crashes, because I'm pretty sure my RAM is getting, yeah, my memory is now 95% due to random background tasks, which should not be happening, and I don't know what's going on there. But in any case, if something crashes, now y'all know why. Okay, so what is the range function? So the range function is what we're using in this instance. If we mouse over it, so it says here that range going from start to stop produces numbers I plus 1, I plus 2, dot, 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 all the way up to the start, to the stop, right? So if we start at 0 and end at -1, 0, 1, 2, 3, those are all positive numbers. So that'll never go to a -1. So it's not going to give you a valid output. So your range will actually fail. And I mean we can test that actually if you want to. So let's just, as a demo, let's print out range 0 -1 and see what happens. So let's run that. Yeah, that's not super helpful.
Is this
But
where you
if
would
you
use
do
the colons?
-1 for the index, that works, right?
What do you mean by that?
So if you're getting the length of the list, you would just do 0 and then stop at -1 with the index brackets around it.
Well, we wouldn't be able to do that to iterate through the list. If you're asking about how to access the thing at the end of the list, so we can say like thing, or we can say end of list item, then you're correct. You could access it like this, my list from -1. That would give you the thing at the last index. But you can't use -1 to iterate through the list that way.
Okay, got you.
Yep. Other questions about that?
You just answered why I've been avoiding for loops for the last month.
Yeah, just think of it really simple. A for loop is you start somewhere, you stop somewhere, and you jump up and down by small amounts. That's all there is to it. So if you think about it like that, it makes it really easy. And if you don't know where to stop automatically, and you're going through a list, just get the length of the list and put it as your stop. Super simple solution.
So I have a question. So
Yeah, go for it.
if we were to like count through the length of the list without using range, would we end up being out of bounds? And does range just make it so that we don't fall out of bounds? It's including from 0 to like, in this case, index 5, which ends up being like the length of the list is 6 without going out of bounds. You know how like in JavaScript, if you do the for loop, you have to do like -1 or whatever so you don't get out of bounds.
Yeah, so this does the same thing. So what this does is this is equivalent in JavaScript for saying for I equals 0, I is less than length of list, I plus plus, or I plus equals 1. This piece of code in JavaScript and this piece of code in Python, same thing. So your 0 is the same. Length of list, your thing before your less than sign is your length of list. And then your 1 is the one right there. So that specifies your upper bound. It's exactly the same. Yeah, good question. So also one thing that may be useful for everyone, as it's not easy learning, much less coding in two programming languages at once. Like that is hard. So something that can make it a little bit easier is if you recognize, hey, there's this thing in JavaScript that looks kind of similar to this thing in Python. I wonder if these mean the same thing. For example, like the similarities here between for loops in JavaScript and for loops in Python, or if and else if constructions. Like noting down for yourself, hey, this Python structure and this JavaScript structure do the same thing. That can be pretty helpful. So I can recommend making like a little cheat sheet or something like that for yourselves for that.
Is there a way that we can avoid making the extra variable length of list when we are using the for loop? Like, is there a method we can call, like a length method or something?
That's exactly what len is.
So if you didn't have the length of list yeah, okay, you actually did what I was talking about. Does that work, or is that just messy, or?
It works. Yeah, I mean, if we want to prove it right now, might as well. I just made the swap. I saved it. And okay, here, let me put in an actual target so I can show you it actually works. Yeah, it works. The only reason I didn't do that in this case is because I like to have more variables just so my code is a little bit more readable. So, for example, let's say that I wrote this code up and then I sent it to Brian. And let's pretend that Brian has never seen this code before, has no clue what it is. He does not have any of the comments that I've written above, just has the code. I want to make my code as easy and interpretable for Brian to read as possible. Or let's say that I don't need to send anyone my code, but I'm going to come back to this code a week from now. And, I never saved any of this stuff. Okay, this is all like stuff. What does any of this mean? I have no idea. Oh boy. Okay, let me read the variable names and the variable names will give you hints for what things mean. Hypothetically, I could replace list to search with ABC. Does that help you understand? And we could replace thing at IDX with XYZ. Does this help you guys understand my code? No, not really. This is why variable naming is pretty important. Even if it's something that doesn't, like makes sense to you and you, well, ideally you and other people, but if it makes sense to you and you only, and if you can write out, hey, this is what list to search is. Like sometimes what people will do right before their function is they'll say like list to search, the list to search. Target the item being searched for in the list. And they'll like write out what their variable definitions are. That is a very helpful way to make your code more readable for other people. So
I guess it's like a constant friction between code readability and efficiency. Because the reason I ask that is like a lot of the curriculum, it'll oftentimes gear up and show you as you progress, like this is how to write it with fewer variables, right? Like ternary operator or something, right? So I'm like, okay, should we be aiming for that? Because I can't read it half the time.
Well, I mean, look, you guys are what, 7, 8 days into the program at this point? For some of you guys, this is your first exposure to a programming language. Your focus should not be on how can I write an entire algorithm in one line. If you want to do that once you have the tool set to. Right now, make code that works and that you can understand, that you can explain to somebody else. That's the goal. If that means that you're going to be defining a new variable maybe not every line, but every 2 lines or every 3 lines to break it out step by step as a process, that is totally fine. And honestly, that's encouraged. If you personally know that you don't have to do that and that's a waste of your time and that your brain is okay with combining steps together, that's totally fine too. Just make sure at the end of the day, when you're showing somebody else or yourself your code, do you know what's going on there? If you do, that's our goal. If not, you might need to reconsider your approach.
So then just to kind of recall what Guillermo said yesterday, he had made a comment about how while loops are very, very advanced, or more advanced than a for loop. And I think it's because you have to know certain aspects of like, you have to know certain things before you use it. It sounds like some of the things are, whereas a for loop, you're given your start, your list, and your increments. And that's why it's very basic, right? It's like a little cooking kit, basically. It's all wrapped up in one, and so you can make a full pot roast without having to go anywhere else, right? So like those little pot roast kits at Walmart. Am I saying that the right way as far as the concept goes between the for loop and the while loop?
Here's what I would say. With the for loop, you know what you're getting into. You know when you're starting, you know when you're stopping, you know how many times you're going to run it. With the while loop, you don't know any of that. Or if you do, it's built into, like that, the while I is greater than 0, and then down in the loop, you've got your, I minus equals 1. Like because of that, it's easier to mess up. So you're not going to get fanciness points by using a while loop instead of a for loop. And to be honest, the standard, most people really, really just use for loops. Like they're easier, they're nicer, they're more mentally palatable. Like it makes more sense to say, I'm going to do this task 10 times versus I'm going to do this task until someone tells me not to do it. Because let's say someone never tells you not to do it. And then, now you're working ad nauseum. So because of that, for loops are recommended more than while loops. I wouldn't say they're more basic or more complicated. I'd just say for the purposes of where you guys are right now, for loops, good. Use them.
Okay.
Understand.
And would you say, so it seems like we're always going to run into a for loop in a lot of these problems. Like, it's not like we've done a lot, but a majority seems like we're running into doing for loops. And so,
I wouldn't assume that. There are cases for while loops.
Gotcha. But as it stands right now, in the beginning, just kind of focus on doing the for loops in the beginning of the course. At least the first quarter of this course is just try using a for loop with the start, stop, and indents.
I would
It's kind of like
focus on understanding why loops exist. Loops exist so that you're not copy pasting code.
okay, gotcha.
That's the simple point. For a for loop, it tells you if you need to if you know you need to copy paste it 10 times, use a for loop. If
Okay.
you don't know how many times you need to copy paste it, use a while loop. That's it. That's it. There's nothing else to it. If you can understand that concept, then you're good with loops. All
Gotcha.
right. So we haven't actually gotten to tonight's lecture yet. So I know usually we take a break around 6:30. I want to push us till 7, and we'll take a slightly longer break at 7 before the assignments. Does that work for everyone? Okay. So I promise that this part of the lecture is going to be a little bit quicker, a little bit easier. So number one, before I get into that though, the first thing I want everyone to do is, you remember that way that we broke down the problem, simple English, and if there's a relevant life example? I want every single person in this call and in this room to do that whenever you see a coding problem. Whether that's in homework, whether that's something that you're doing in an interview, whether that's like a hacker rank or a coder bites challenge, I want you guys to do this. It doesn't matter if it takes you half an hour, but breaking down the problem into simple English, number one, and into a series of steps for you to follow is going to be your ticket to success, to put it very bluntly. Because this is how you break down a problem into its parts. After you break down the problem, then you start writing code, and you don't just start coding immediately. Like what I was doing with you all is I was going item by item. List of things, okay, that's going to be in my function argument. Things defined, that's also in my function argument. All right, going through the list, all right, that's going to be how do I do that? I need to break that into these different parts. So go through your lists, or go through the list of steps that you need to do and code out each step individually. Test each step individually. Like make this a systematic flow. That will help you all immensely with this process. So I will be coming around to check with everyone to make sure that you all are following this, because building in these habits as early as possible is a good thing. All right, that's the rant over. So let's move on to testing. So down here, we did a couple tests, right? We printed out like the my target is B. We checked these small examples. We have our print statements, but there's a better and easier, or not easier, there's a better way to do it that's more systematic. And this is called using something called test-driven development, or TDD. TDD is a fancier way of saying, I'm going to write some code, and once it's done, I'm not going to assume my code is right. I'm going to check it with a bunch of tests, and if it passes all the tests, then my code's good. If my code fails the tests, my code is not so good. So in Python, the way that we do these tests, you can do it via print statements, which is nice and easy and quick, because that's what I like to do. Or you can do it by using something called PyTest. So we're going to install the PyTest library using pip, which I think everyone should know how to do. And we'll give it a second to install here. And yes, so Joshua, so TDD is a concept that encompasses Jest, that encompasses PyTest, etc. But PyTest is the equivalent of Jest in JavaScript. So it's the Python version of Jest, basically. All right, great. So we've installed that. We'll just see if PyTest shows up here. Okay, let's do a pip list, actually. Sorry. And let's just make sure that we have PyTest shows up in that list. Awesome. So my installation worked. So the first thing that we're going to need to do is, because this is a package, I'm going to need to actually, here, let me rename this from TDD.py. Let's call this linear search.py. And so the last instruction was just to type pip install PyTest. So just put that in your console and run it. So I'm going to go ahead and just make a new file, and we'll make that my tdd.py, and we'll work on it in there. So the first thing that I want to do is let's see. So I'm going to first need to import import PyTest. Actually, sorry, no, we shouldn't need to do that. So just disregard that part. The first thing that we're going to need to do is we're going to want to import our function. So let's go ahead and import our linear search function, which we just called linear search. Just call this linear search function. And I'll save that. I'll switch files, and I'll say from linear search, I want to import my linear search function. And now I'm going to write a test function for this. So we're going to say define test linear search. And let's come up with a test list. We're going to say test list is going to be A, B, C, 1, 2, 3, X. Okay. And let's also now put in a test target. So test target, and let me use some underscores because I like using underscores. Test target. Let's do C. So the index of C in this list, 0, 1, 2. So we know target indexed should be equal to, so target index should be equal to 2, right? We know this based on the list that I created. But the thing I want to check is whether my linear search result is also equal to 2. It might not be. Right? I don't know what my function is going to output. So what we want to do is we want to assert whether or not the linear search function that's going to run on my test list, or no, test list, and then test target. I want to make sure that this is equal to my actual target index or not. So let's see what happens. So let's do, let's see, so PyTest TDD.py. Okay, that should definitely not be happening. Let me see if it didn't work. Okay, this is weird. Give me a second to pause the recording and then we'll talk. So if it works, if you pip install it, then you run PyTest, this is what you should get. So you should see that says test session starts, and it didn't do anything. So if we run the code that I now have in my tdd.py, usually what we'd do is we'd say Python tdd.py, right? But in this case, we're going to say PyTest tdd.py. So let's see what happened here. So it starts a test session, and it says here's where it's running it, right? It's running it in Python with this version, this PyTest version. It was one item, one test that it ran. It ran it with a green dot, so that's a good sign. And it says it passed one test in 0.03 seconds. What does that mean?
Means your code works.
Yeah, it means the code works. Successful. That's a good thing. So let's run a couple other tests while we're at it. So let's do test 2, and let's change the target to 3. 0, 1, 2, 3, 4, 5. So let's check if it searches for 3, that finds it there. And then let's write in one more test, just for the heck of it. Let's say that we are going to search now for this thing. This thing does not exist in the list, right? So it should return none. And we want to check that when we're testing our function, it's going to actually return none. So we now have 1, 2, 3 tests in here. So when I run this with PyTest, it should check all 3 tests, which should hypothetically succeed. And we see now that all 3 tests succeeded, right? It says all 3 of them passed. It shows you down here how many tests it ran, and the color, which is green, shows you that they succeeded. Now, let's say, hypothetically, that if something does not exist in this list, we want it to return -1 instead of none. Now, what does our function actually return? Our function returns none. But here we're going to check if none is equal to -1, which is false. So this last test should fail. Let's check if it does or not. So let's rerun it. Oh boy, this looks bad. So we get 2 successful tests and then a nice big F, which is a failure. Now, the good thing about PyTest is it shows you exactly where the failure happened. So it says assert none is -1, and it says where none is the output of my function. So this is great. It tells us which test failed. It tells us what the expected result is versus the actual result. And it tells us what the actual result is derived from. So this helps us out a lot with debugging. So I'll change this back to none, and then it all succeeds again. So that's like your very basic 101 for how to do test-driven development. There's a couple of different types of assertions that you can use. Right? So here we could say, here we're doing assert equals, which is just checking, is the thing on the left equal to the thing on the right? We could also do an assert not equals. Let's say that we want to check that the result of this last test is that this thing is not found at index 0. So we can do a not equals to check if it's not equal to index 0. And we see that passes. You can also do an assert equal, which is different from assert. So assert equal between thing 1 and thing 2. That you generally want to use this when comparing complex objects like lists, class instances, dictionaries, aka things where like an equal sign just isn't gonna cut it. You can also do assertions with like equal with greater than and less than signs, or check if something's in a list or not in a list. But in general, the main type of assertion you'll use like 99% of the time is going to be assert double equals or assert equal. There's a lot of other types, but they're pretty self-explanatory, and I think the README for today goes through them. But the main thing you're going to use is this assert with the double equals. You can also check if a thing is sorted. Sometimes you want to output a sorted list, and you can assert sorted to check if it is if it's sorted or not. And yeah, that's really about it. So use PyTest like you would use Jest in JavaScript. Same thing. Use this to test your outputs, test your functions after they're written. Don't do it while you're writing your function. Do this after your function's written. Also, when you're designing test cases, design your test cases based on the problem description. So in my case, right, we wrote 3 test cases. 2 test cases were answering this middle part. Does it return the correct index of the search term? But the last test we did answers this last part. If the object is not found, does my code return none? So write your tests to the specifications of the problem. That's really about it for lecture. So we talked a bit about how to translate a problem from complicated code-ish language to simple English, to example, to line-by-line comparison between your path that you outlined and writing your code. We talked about testing your code while you're writing it using print statements, make sure it's doing what you want it to do. I talked a little bit about the difference between for and while loops, and we tested this function out in here. We also debugged a little bit of PyTest which again, highly recommend you use. It's just like Just. And then we talked a little bit about how to write some tests using Python. Any questions before we take our break? I know this was a lot, so.